Hey y'all, I just wanted to make some quick videos to help you in the topics in homework 5 that we didn't get a chance to get to. This video covers maximums and minimums. So when we're talking about maximums and minimums, these are the points that are higher than other things or lower than other things. Maximums are higher than other things and minimums are lower than other things. Now, we are going to have local maxes and mins, and we're going to have absolute maxes and mins. So let's start with the difference between these. So a local maximum is basically just a high point that's just local. So it's really a point that's higher than anything directly around it. It doesn't have to be the absolute positive highest point on your function. It just has to be higher than the stuff right around it to be a local maximum. You can have several of these on the same function. Several in the same function. And you're going to include the tops of all hills. So any point that's higher than the stuff directly around it is going to be at the top of a hill. So any point that's at the top of any hill, you're going to include as a local maximum. You can have lots of these. Similarly, a local minimum is a point that's lower than anything directly around it. Doesn't have to be the absolute positive lowest point in the whole function. It is any point that's lower than the stuff just around it. Again, we can have several of these on the same function. So what that means is you're going to include the bottom of all valleys. Okay, and then these last two, absolute maxes and mins. So if I tell you that I'm looking for the absolute maximum, what does that mean? That means the single highest point a function achieves. Single. That means only one per function. So it is the one highest point that a function achieves. Now, something that I want you to make a note of is that the function has to achieve that maximum. There must be a point there that is higher than anything else. We have to hit that high point. There has to be a point there, and it has to be clear um, that there's a function value there. That's the biggest one. Similarly, the absolute minimum is going to be the single lowest point a function achieves. The one point that's lower than anything in the function. Again, single means there's only one per function. So that's kind of the biggest difference between a local max and an absolute max is that locals, you can have several of those. You want to include the tops of every hill, but in absolute, you only want the single highest. Um, so that's kind of the difference between these. So let's try this out. So I have an example here where I have a graph. This is the graph of f of x, and I want to list all local maximum values and B, the location of all local maximum values. Now, kind of the thing that's going to be confusing about this in ALEKS is whether it's asking for the x values or the y values. As a rule, if it's asking for a maximum value or a maximum function value, that means it wants y. If it's asking for the location of a maximum or minimum value, the locations are where a max or min happens. That's the x value. The x value is where it happens. The y value is the maximum value or the function value itself. So that's going to be kind of the biggest confusing thing about this. So let's start with A here. List all local maximum values. And again, I want max values. I'm looking for the y values of the maxes, the things that are higher than the things around it. And this is local, so I want to include the top of every hill. So top of every hill is here and here. So the local maximum values are the y values associated with these. So 2 and 0 are my local maximum values. You can just list them with a comma in between. Those are our local max values. The next one, list the locations of all local max values. Locations of means x values. So again, I'm looking at these local maxes, but this time I want to know where they happen. I'm looking at the x values associated with them. So this big max up here happens at x equals -4. And this max over here happens at x equals 1. All right. Those are our local maximums. Okay. So now let's switch to local mins. So we want the local minimum values. Local means I'm going to list all minimums, which means any bottoms of any valleys. And minimum values is what they're looking for here. That means the y values. So all local minimum values. So here's a bottom of a valley, and here's a bottom of a valley. So I want the y values where each of these points take place. So this one down here has a y value of 2. And this minimum over here has a y value of -1. So I'm just going to list those out. And then D, the locations of all local mins. That means I'm looking for the x values because it wants the location of, it wants to know where this happens. That's an x value. So now I'm going to come back to these local mins and I'm going to refer to them by the x values that go with them. And so the x values that I'm looking at here are -1 and 3. Okay, that took care of our local mins. And then the very last one here, we'll do our absolute max values. So again, absolute maximum values, it wants a max value, it wants a y value. This is asking for the single largest y value that this function hits? Well, this kind of looks like it might be an absolute max, except this part of the function over here keeps going. And I've got points here that are higher than this one reached. So that's not an absolute maximum. Now, so what is our absolute maximum here? That arrow says this thing keeps going forever. So does that mean infinity is going to be my absolute maximum value? Well, again, to be an absolute max value, the function must achieve that value. The function must actually hit that value. We're going to continue on forever in search of y equals infinity. But y equals infinity is an idea. It's not a value that this function is ever actually going to hit. There's always going to be another point that's higher than every point. It doesn't matter how far this function climbs, it's going to climb further. So this actually doesn't have an absolute maximum value. There is not a single highest point that this function hits. All right, part F. List any absolute minimum values. Again, absolute means the one single lowest value that this thing achieves, and we want minimum values, so we're looking for the y values. What is the absolute lowest value that this function hits? Well, this is the lowest of our locals, but that's not our absolute minimum because I've got y values here that are lower than that one, so that can't be my absolute min. And this arrow says we're going to continue on forever, but negative infinity can't be an absolute minimum because we're never going to reach it. We're not going to have that single lowest point that's lower than anything else because our function's always going to keep on going, which means we also don't have an absolute minimum value either. So even though you can have a at most one absolute max and min, you don't always have one. All right, let's do one last one here. All right, we want to list all local maximum values. So we're going to list the y values of all of our local maximums. So the tops of all of our hills is just this one. So the y value of that point is 3. The location of, that means the x value of the local maximums. Well, again, this is the only top of the hill we have. The x value that's associated with that point is x equals 1. So that's the location of our local maximum. Next one, we are asked for the local minimum value. Local means the bottom of any valley, and we're looking for the minimum values. I want the y value of those points. So if we look up here, our mins, the bottoms of our valleys happen here and here. The y values associated with those are 1 and -2. So I'm just going to list those out. Part D lists the locations of, that's an x value, of the local mins. So again, the bottoms of those valleys, we're going to refer to them by the x values, the location. So we've got -3 over here and 4 over here. Those are the locations of our local mins. All right, now we're looking for absolutes. The absolute maximum values, we are looking for max value, we're looking for a y's. We're looking for the highest y value that this function achieves. Oh, but again, this function continues up forever. which means we are never going to reach a highest point. There's always going to be another point higher than where we're at. We don't hit infinity. Okay, how about absolute minimum values? Again, minimum values, that means y. We are looking for the single lowest y value that our function achieves, and this one has one. This point is the absolute lowest point that our function reaches anywhere on the whole function. And so that's our absolute min. Now, we want to list the absolute minimum value, which means the y value. I'm going to refer to this point by its y value, which is -2. All right, that is maximums and minimums. I hope this is helpful with homework 5, and I will see you next time.